Let us now jump in and get started with our basic exercises. So I will jump into the first exercise, which is retrieve everything from a table. So here I have my question, and how can I get all the information I need from the facilities table? And as you know, all my data is represented here, so I can check here to see where I can find the data that I need. Now, as I write my query, I aim to always start with the from part. Why start with the from part? First of all, it is the first component that runs in the logical order. So again, if I go back to my chart over here, I can see that the from component is the first. And that makes sense, right? Because before I do any work, I need to get my data. So I need to tell SQL where my data is. So in this case, the data is in the facilities table. Next, I need to retrieve all the information from this table. So that means I'm not going to drop any rows, and I'm going to select all the columns. And so I can simply write select star. And if I hit run, I get the result that I need. Here in this quadrant, I can see my result, and it fits the expected results. Now the star is a shortcut for saying, give me all of the columns of this table. So I could have listed each column in turn, but instead I took a shortcut and used a star. Retrieve specific columns from a table. I want to print a list of all the facilities and their cost to members. So as always, let's start with the from part. Where is the data that we need? It's in the facilities table again. And now the question is actually not super clear, but luckily I can check the expected results. So what I need are two columns from this table, which is name and member cost. So to get those two columns, I can write select name member cost. Hit run, and I get the result that I need. So if I write select star, I'm gonna get all the columns of the table, but if I write the name of specific columns separated by comma, I will get only those columns specifically. Control which rows are retrieved. We need a list of facilities that charge a fee to members. So we know that we're going to work with the facilities table, and now we need to keep certain rows and drop others. We need to keep only the rows that charge a fee to members. So what component can we use in order to do this? If I go back to my components chart, I can see that right after from, we have the where component. And the where component is used to drop rows that we don't need, right? So after getting the facilities table, I can say where member cost is bigger than 0, meaning that they charge a fee to members. And finally, I can get all of the columns from this. Control which rows are retrieved, part 2. So like before, we want a list of facilities that charge a fee to members, but our filtering condition is now a bit more complex because we need that fee to be less than 1/50th of the monthly maintenance cost. So I copied over the code from the last exercise. We're getting the data from our facilities list, and we're filtering for those where the member cost is bigger than 0. And now we need to add a new condition, which is that fee, which is member cost, is less than 1/50th of the monthly maintenance cost. So I can take monthly maintenance over here and divide it by 50, and I have my condition. Now when I have multiple logical conditions in the where, I need to link them with the logical operator so SQL can figure out how to combine them, because the final result of all my conditions needs to be a single value, which is either true or false, right? So let's see how to do this. In my mental models course, I introduced the Boolean operators and how they work, so you can go there for more detail. But can you figure out which logical operator do we need here to chain these two conditions? As suggested in the question, the operator that I need is AND, so I can put it here. And what AND does is that both of these conditions need to be true for the whole expression to evaluate to true and for the row to be kept. So only the rows where both of these conditions are true will be kept, and all other rows will be discarded. Now to complete my exercise, I just need to select a few specific columns because we don't want to return all the columns here. And I think that I will cheat a bit by copying them from the expected results and putting them here. But normally you would look at the table schema and figure out which columns you need. And that completes our exercise. Basic string searches produce a list of all facilities with the word tennis in their name. So where is the data we need? It's in the CD facilities table. Next question, do I need all the rows from this table or do I need to filter out some rows? Well, I only want facilities with the word tennis in their name, so clearly I need a filter. Therefore, I need to use the where statement. How can I write the where statement? I need to check the name and I need to keep only facilities which have tennis in their name. So I can use the like statement here to say that the facility needs to have tennis in its name, but what these wildcards signify is that we don't care what precedes tennis and what follows tennis. It could be 0 or more characters before it and after it. We just care to check that they have tennis in their name. And finally, we need to select all the columns from these facilities. And that's our result. Beware, like I said before, of your use of the quotes. So what you have here is a string. It's a piece of text that allows you to do your match. Therefore, you need single quotes. If you, as it's likely to happen, used double quotes, you would get an error here, and the error tells you that the column tennis does not exist because double quotes are used to represent column names and not pieces of text. So be careful with that. Matching against multiple possible values. Can we get the details of facilities with ID 1 and ID 5? So where is my data is in the facilities table. And do I need all the rows from this table or only certain ones? I need only certain rows because I want those that have ID 1 and ID 5. So I need to use a where statement. Now, what are my conditions here? Their ID, actually facility ID equals 1 and facility ID equals 5. So I have my two logical conditions. Now, what operator do I need to use in order to chain them? I need to use the OR operator, right? Because only one of these needs to be true in order for the whole expression to evaluate to true. And in fact, only one of them can be true because it's impossible for the ID of a facility to be equal to 1 and 5 at the same time. Therefore, the AND operator would not work, and what we need is the OR operator. And finally, we need to get all the data, meaning all the columns about this facility, so I will use select star. The problem is now solved, but now let's imagine that tomorrow we need this query again and we need to include another ID, ID 10. So what we can do is put OR facility ID equals 10. But this is becoming a bit unwieldy, right? Because imagine having a list of 10 IDs and then writing OR every time, and it's not very scalable as an approach. So as an alternative, we can say facility ID in and then list the values like 1 and 5. So if I take this and make it into my condition, I will again get the same result. I will get the solution, but this is a more elegant approach and it's also more scalable because it's much easier to come back and insert other IDs inside this list. So this is a preferred solution in this case. And logically, what in is doing is looking at the facility ID for each row and then checking whether that ID is included in this list. If it is, it returns true, therefore it keeps the row. If it's not, returns false, therefore it drops the row. And we shall see a bit later that the in notation is also powerful because in this case we have a static list of IDs. We know that we want IDs 1 and 5, but in more advanced use cases, instead of a static list, we could provide another query, a SQL query or a subquery that would dynamically retrieve a certain list, and then we could use that in our query. So we shall see that in later exercises. Classify results into buckets. Produce a list of facilities and label them cheap or expensive based on their monthly maintenance. So we want to get our facilities. Do we need a filter? Do we need to drop certain rows? No, we actually don't. We want to get all facilities and then we want to label them. And we need to select the name of the facility, and then here we need to provide the label. So what SQL statement can we use to provide a text label according to the value of a certain column? What we need here is a case statement which implements conditional logic, which implements a branching, right? It's similar to the if-else statements in other programming languages, because if the monthly maintenance cost is more than 100, then it's expensive. Otherwise, it's cheap. So this calls for a case statement. Now, I always start with case and end with end, and I always write these at the beginning so I don't forget them. And then for each condition, I write when and what is the condition that I'm interested in. Monthly maintenance being above 100. That's my first condition. What do I do in that case? I output a piece of text which says expensive. And remember, single quotes for text. Next, I could write the next condition explicitly, but actually, if it's not 100, then it's less than 100. So all I need here is an else. And in that case, I need to output a piece of text which says cheap. And finally, I have a new column and I can give it a label. I can call it cost. And I get my result. So whenever you need to put values into buckets or you need to label values according to certain rules, that's usually when you need a case statement. Working with dates. Let's get a list of members who joined after the start of September 2012. So looking at these tables, where is our data? It's in the members table. So I will start writing this. And now, do I need to filter this table? Yes, I only want to keep members that joined after a certain time. And now, how can I run the condition on this table? I can say where join date is bigger than 2012 September 01. So luckily in SQL and in Postgres, filtering on dates is quite intuitive. Even though here we have a timestamp that represents a specific moment in time up to the second, we can say bigger or equal actually, because we also want to include those who joined on the first day. We can write bigger or equal and just specify the date, and SQL will fill in the rest of the remaining values and the filter will work. And next we want to get a few columns for these members. So I will copy paste here, select, and this solves our query. Removing duplicates and ordering results. We want an ordered list of the first 10 surnames in the members table, and the list must not contain duplicates. So let's start by getting our table, which is the members table. Now we want to see the surnames. So if I write this, I will see that there are surnames which are shared by members, so there are actually duplicates here. So what can we do in SQL in order to remove duplicates? We have seen in the mental models course that we have the distinct keyword, and the distinct is going to remove all duplicate rows based on the columns that we have selected. So if I run this again, I will not see any duplicates anymore. Now the list needs to be ordered alphabetically, as I see here in the expected results, and we can do that with the order by statement. And when you use order by on a piece of text, the default behavior is that the text is ordered alphabetically, and if I were to use descending, then it would be ordered in reverse alphabetical order. However, that's not what I need. I need it in alphabetical order. So now I see that they are ordered. And finally, I want the first 10 surnames. So how can I return the first 10 rows of my result? I can do that with the limit statement. So if I say limit 10, I will get the first 10 surnames. And since I have ordered alphabetically, I will get the first 10 surnames in alphabetical order. And this is my result. Now, going back to our map over here, we have the from, which gets a table. We have a where, which drops rows that we don't need from that table. And then all the way down here, we have the select, which gets the columns that we need. And then we have the distinct, right? And the distinct needs to know which columns we need because it drops duplicates based on these columns. So in this example over here, we're only taking a single column, surname, so the distinct is going to drop duplicate surnames. And then at the end of it all, when all the processing is done, we can order our results. And then finally, once our results are ordered, we can do a limit to limit the number of rows that we return. So I hope this makes sense. Combining results from multiple queries. So let's get a combined list of all surnames and all facility names. So where are the surnames? They're in CD members. And from CD members, I can select surname, right? And this will give me the list of all surnames. And where are the facility names? There are in CD facilities, and I could say select name from CD facilities, and I would get a list of all the facilities. Now we have two distinct queries, and they both produce a list or a column of text values, and we want to combine them. What does it mean? We want to stack them on top of each other, right? And how does that work? Well, if I just say run query like this, I will get an error because I have two distinct queries here and they're not connected in any way. But when I have two queries or more defining tables and I want to stack them on top of each other, I can use the union statement, right? And if I do union here, I will get what I want because all the surnames will be stacked vertically with all the names, and I will get the unique list containing both of these columns. Now, as I mentioned in the mental models course, typically when you have just union, it means union distinct, and actually Other systems like BigQuery don't allow you to write just union. They want you to specify union distinct. And what this actually does is that after stacking together these two tables, it removes all duplicate rows. And the alternative to this is union all, which does not do this. It actually keeps all the rows. And as you know, we have some duplicate surnames and then we get them here and it doesn't fit with our result. But if you write just union, it will be union distinct and you won't have any duplicates. And if you look at our map for the logical order of SQL operations, we are getting the data from a certain table and filtering it and then doing all sorts of operations and on this data. And then we are selecting the columns that we need. And then we can remove the duplicates from this one table. And then what comes next is that we could combine this table with other tables, right? We can tell SQL that we want to stack this table on top of another table. So this is where the union comes into play. And only after we have combined all the tables, only after we have stacked them all up on top of each other, we can order the results and limit the results. Also remember, and I showed this in detail in the mental models course, when I combine two or more tables with a union, what I need is for them to have the exact same number of columns, and all of the columns need to have the same data type. So in this case, both tables have one column, and this column is a text, so the union works. But if I were to add another column here, and it's an integer column, it would not work because the union query must have the same number of columns, right? I will get an error. However, if I were to add an integer column in the second position in both tables, then it would work again because again, I have the same number of columns and they have the same data type. Simple aggregation, I need the sign up date of my last member. So I need to work with the members table and we have a field here which is join date, and I need to get the latest value of this date, the time when a member last joined, right? So how can I do that? I can take my join date field and run an aggregation on top of it. What is the correct aggregation in this case? It is max, because when it comes to dates, max will take the latest date, whereas min will take the earliest date. And I can label this as latest and get the result I need. Now, how aggregations work, they are functions that look like this. You write the name of the function and then in round brackets you provide the arguments. The first argument is always the column on which to run the aggregation, and what the aggregation does is that it takes a list of values, could be 10, 100, a million, 10 million, it doesn't matter. It takes a long list of values and it compresses this list to a single value. It does like we've seen in this case, taking all of the dates and then returning the latest date. Now to place this in our map, we get the data from the table, we filter it, and then sometimes we do a grouping, which we shall see later in the exercises. But whether we do grouping or not, here we have aggregations. And if we haven't done any grouping, the aggregation works at the level of all the rows. So in the absence of grouping, as in this case, the aggregation will look at all the rows in my table, except for the rows that I filtered away. But otherwise, it will look at all the rows and then it will compress them into a single value. More aggregation. We need the first and last name of the last member who signed up, not just the date. So in the previous exercise, we saw that we can say select max join date from members, and we would get the last join date, the date when the last member signed up, right? So given that I want the first and the last name, you might think that you can say first name and surname in here, but this actually doesn't work. This gives an error. The error is that the column first name must appear in the group by clause or be used in an aggregate function. Now, the meaning behind this error and how to avoid it is described in detail in the mental models course in the group by section. But the short version of it is that what you're doing here is that with this aggregation, you're compressing join date to a single value, but you're doing no such compression or aggregation for first name and surname. And so SQL is left with the instruction to return something like this. And as you can see, here we have a single value, but for these columns, we have multiple values. And this does not work in SQL because you need all columns to have the same number of values. And so it throws an error. And what we really need to do here is to take this maximum join date and use it in a where filter, because we only want to keep that row which corresponds to the latest join date. So we can take the members table and get the row where join date is equal to the max join date. And from that, select the name and the surname. Unfortunately, this also doesn't work. So what we saw in the course is that you're not allowed to use aggregations inside where. So you cannot use max inside where. And the reason why is actually pretty clear, because aggregations happen at this stage in the process, and aggregations need to know whether a group by has occurred or not. They need to know whether they have to happen over all the rows in the table or only within the groups defined by the group by. And when we are at the where stage, the group by hasn't happened yet, so we don't know at which level to execute the aggregations, and because of this, we are not allowed to do aggregations inside the where statement. So how can we solve the problem now? Well, a sort of cheating solution would be if we knew the exact value of join date, we could place it here, and then our filter would work. We're not using an aggregation, and we could put join date in here to display it as well, and that would work. However, this is a bit cheating, right? Because the maximum join date is actually a dynamic value. It will change with time. So we don't want to hard code it. We want to actually compute it. But because this is not allowed, what we actually need is a subquery. And the subquery is a SQL query that runs within a query to return a certain result. And we can have a subquery by opening round brackets here and writing a query. And in this query, we need to go to the members table and select the maximum join date. And this is our actual solution. So in this execution, you can imagine that SQL will go here inside the subquery, run this, get the maximum join date, place it in the filter, keep only the row for the latest member who has joined, and then retrieve what we need about this member.